Now here, question 35, it states the guidance department has reported that of the senior class, 2.3% are members of Key Club, which let's just highlight this, which we're going to call that K, and also 8.3% are enrolled in AP Physics, which is going to call that P, and 1.9% are involved. Okay. So it says here, well, let's determine the probability of P given K to the nearest tenth of a percent here. Now to find the probability of P given K, we're pretty much asked to find a conditional probability. So what we want to do here is we want to find the conditional probability. Okay, now if you remember, the formula for a conditional probability is the probability of A, well in this case, the two events, which is P and K. So we want to find the probability of P and K. And we're going to divide that by the probability of K. This is just because we know that we want to find the probability of P given K. We know that's a conditional probability. And a conditional probability states, well, you find the probability of P and K, and you divide by the probability of K, then you have the probability of P given K. All right, well, but we do have those. The probability of P and K, it's given right here in 1.9 because they're both 1.9% are that are in bold. So we got 1.9% divided by the probability of K. Well, here it is 2.3% are members of a key club, which is K. So the probability for K to happen is 2.3%. But here we cannot divide percentages, so we gotta convert this into decimal form. So 1.9%, we're just gonna call that. Here we cannot divide percentages, so let's just convert that into decimal. So that will be 1.9%, that will be 0.19. That will be divided by 0.23. And if you do this in the calculator, that will be 0.826, which all we gotta do is just convert this into percentage. So that gives us 82.6%. Great. So we know that this is the probability of P given K. But this is not all they're asking us, at least in example 35 here. In example 35, oops, you already saw 36 here. So in example 35, now here it's stating that the principal would like a basic interpretation of these results. Let's write a statement relating what we found out on the previous section here. So let's make sense of what we obtained here. We found out that the probability of P given K is equal to 82.6%. But what is P and what was K? Well, let's come back to the problem here. It says P are those who are enrolled in AP Physics, and K are those who are enrolled in the K Club. So what does that mean for us to find the probability of P given K? That means that we pretty much want to find out, given K, given K, which is the number of K Clubs members, if we've been given K, so if we're looking at the K Club members, what is the probability that they're also in AP Physics? Because we've been given K, then we first look at the group of individuals who are in the group of K, which is K Club members. And then out of that population, we're going to see which of those K Club members also belong in AP Physics. And we found that out to be 82%. So given K is what happens first. We first are being given K, which is we're first looking at the K Club members. And if we group them all, we also want to see which of those Key Club members also are enrolled in AP Physics. And we found that out to be 82.6. So that's pretty much the interpretation that we can write out here. Where if we want to interpret here, we want to write down that, well, a Key Club member it has an 82.6% probability of being enrolled also in AP Physics. So we first look at those which are the Key Club, and then we took a closer look to see which of those Key Club members also belong in AP Physics, and we found that out to be 82.6%. Now here, in question 36, this problem looks a little bit intimidating, but all we have to do here is, well, notice the first statement here says using the formula below. So before we even start looking at the actual problem, we already been told what to do here. Let's just use the formula below. So here, this is the formula that is speaking of. So we have this formula, but what about this formula? It has different variables, but we know what each of those variables represent here. So our first job is to find out, well, what's the value for each of those variables? If we want to use the formula, we need to know what's the value of those variables. We plug that in, and we get our answer out. All right, so let's look at here. It says, using the formula below, determine the monthly payments on a 5-year car loan. So this looks important. So we have here, we're looking at a 5-year loan with the monthly percentage of 0.0625 for a car with the original cost of 21. So the original cost is 21 and a 1,000 down payment, 20%. Okay. So let's see, can we find out what P of n stands for? Well, P of n is a present amount borrowed. So is the amount that you have borrowed here, which pretty much is going to be the original cost minus a down payment. Okay, now let's think about it. The present amount borrow, it's you borrow a certain amount of money, you put a down payment, which pretty much you're saying you pay a little bit of it back. So that pretty much gives you what is the present amount borrow. So, but we have this information here. We know that the original cost is 21,000, and we know that the down payment is 1,000. So that says that P of n has a value of 20. Okay, so at least we know what P of n is. All right, so let's see. Do we know what n stands for? N is the number of monthly pay periods. Okay, so let's see here. It says determine the monthly payment for a 5-year car loan with the monthly percentage of. Okay, so we know that n is the number of monthly pay periods. We know that we're looking at a 5-year plan, but how many months are in a year? Well, that would be 12. So that means that he will be making 60 payments in total throughout the 5 years. And that would be the number of monthly payment periods. So you got 5 years, every year has 12 months. So that means that you will be making 60 monthly payments here. So, and that is the number of monthly pay periods here. So at least we know what n is. PMT, well, that's kind of like what we're looking for here. Because the monthly payments, that's kind of like what they're asking us here. Determine the monthly payments. So if we determine what the monthly payments are, we don't know what this is. We don't know what the monthly payments are. So at least in this case, PMT, this is what we're looking for. Now, do we know the value of I? Well, it says here that I is an interest rate per month. Well, let's read here. It says with a monthly percentage rate of 0.625. So this is telling me that I is equal to 0.625%. but you will always want to put this in decimal form. So if you divide it by 100, you will get 0.00625. Great. So I think we have all we need. We have a formula. We have values for this formula. We know what P of n is. We know what n is. We don't know what PMT. And we know what I is. We have a formula. Let's plug that in. Let's plug that in and see what happens here. All right. Sorry about that. Hold on. What happened here? Oh, I know what happened. Cool. So let's plug that in, man. Let's just plug that in. So here we have a formula where our formula says P of n, which we know the value of P of n. P of n is 20,000. So we got 20,000 equals PMT, but we don't know what PMT is. So let's just write it out as PMT. Big parenthesis, 1 minus, okay? So 1 minus, parenthesis, 1 plus, I. But notice that we know the value of I. I is right here, 0.00625. So that will be minus 0.00625. Close the parenthesis, minus n. But we know that n is 60 here. So that'll be minus 60. And we will need to divide this by I. But we know that the value of I, we know here the value of I is 0.00625. Great. Now, the trick here is what we want to do here, essentially. This is what we want. We want PMT. But notice that all this is an actual number here. All this is actually a number here. So the strategy here, find out what this is, put them in the calculator. And if we do this in the calculator, which I'm not going to show it here, we're going to get PMT times, if we do all this expression, the whole expression, the calculator, you will get that we're going to get 49.9053. So now we have the following. We have 20,000 equals PMT times 49.9053. If you want to solve for PMT, divide on both sides. This cancels out. So now we know that PMT is equal to 20,000 divided by 49.953. And if we do this in the calculator, you will see that this is equal to 400.76. So we know that PMT is equal to 400 with 76 cents. So now here what they're saying is, well, let's switch it up. Let's switch it a little bit. Here it says for the affordable monthly payments. So now the monthly payments are 300, and we're still talking about the same time period. Now here we're looking for something different here. Here they're asking us, well, determine an appropriate down payment to a nearest dollar. Okay, well, at least, well, let's write down what we have here. Again, well, if you want to use the formula, we better know the value of those variables. So let's write them down here. Let's see. We know that PMT here is 300. They're giving it to you right here because it says an affordable monthly payments, and PMT is the monthly payments. So they're giving us PMT to be 300. So now, what else should we look at? We need to know what PN is. But notice that PN, just like it was described here on the top, Pn is the original minus the down payment. Okay, so at least the original is still the same, 21. But now, if we look at this example here, this is kind of like what we're looking for. They're asking us to determine an appropriate down payment. We don't know what a down payment is, so let's just put an x on it. So that means that P of n is 21 minus x. We don't know what the down payment is, so we're just going to put an x on it. And it says that pretty much the same. It says determine an appropriate down payment to nearest 10 for the same time period. So we still can use the same value of I, which is going to be 0.0625. And we still can use the same value for n, which is 60. All right, we have a formula. Now we got new values. Let's plug in what we know. And if you look at your formula on top, we have the P of n, which we know is to be 21 minus x. So this is just information here. So we're going to have 21 minus x equals, we have PMT, which we know is 300, parenthesis, and now we have 1 minus 1 plus I, but we know that I is 0.06, 0.00625, close parenthesis, 60 now. So notice that it's pretty much the same here. And we are going to divide this by 0.0025. Perfect. So notice that here, what we have here, if you put all this in the calculator, the whole right side, which I'm not going to show here, you will obtain 147159.245. And that was pretty straightforward to solve for x. Again, all we did here, we looked at what is the value of this. You can put it in the calculator. What I will suggest is to find what this is by putting in the calculator and then multiply by 300. And that's how we arrive to this number here. So now you want to solve for x. Well, you got to subtract 21. So now we have negative x equals negative 60, 28.40. And again, do you want to, your answer should always be with a positive x. So let's divide it by negative 1. That cancels out. And all we got to do here is just change the sign. So this means that x has a value of 60, 28.40. Cool. Perfect. Again, all you need to do for this problem is just to really identify the information that is being given to you. All right, so we're down to the last problem. Finally made it. Example 37. In example 37, let's see what they're asking us here. It says, the speed of a tidal wave, which we're going to call that s, in hundreds of miles per hour, can be modeled by the equation. All right, so we have an equation in here, let's highlight it, where t represents the time from its origin in hours. Okay, so that's in hours. Now the question here is saying, well, algebraically, let's determine the time when s is 0. So we have a formula. We know that t represents time. And our job is to see what is the value of t when s is 0. So what we have here is, we have our formula, s equals square root of t minus 2t plus 6. We want to know what happens when s is 0. So let's plug that 0. Okay, so what's happening here is that we want to solve for t now. So every time that you have a square root on t, what I will suggest for you to do is leave the square root alone, or isolate the square root. So let's start beginning by isolating the square root. You do that, you get 2t equals the square root of t plus x. And again, what I'm doing here, or what we're doing here, is that we're trying to isolate the square root. So now we have 2t minus x equals the square root of t. Now, why do we want to isolate the t here? Well, because the moment that it's isolated, what we can do here, we can take the square to both sides. And notice what's going to happen on the right side. Here, it cancels. You just cancel it out. And now, let's see what we have on the right side. 2t minus 6, and again, 2t minus 6 to the second. This is equal to writing 2t twice. I don't think I'm going to have space here. 2t minus 6. You write it twice. So knowing that, we can solve the following. So 2t minus 6, this is pretty much saying 2t minus 6 times 2t minus 6. This is equal to t now. Now, notice that here, you can distribute. So 2t and 2t, that's 4t squared. 2t and negative 6. So that's negative 12. Negative 12t. Now you distribute this once more, you get another negative 12t. You distribute this once more, you get positive 36 equal to t. Now, if you want to solve this, you got to let your equation be equal to 0. So minus t. But before we do that, actually, we want to combine these two. So now we have 4t squared minus 24t plus 36 equal to t. Now, let's subtract that t here. So now we have 4t squared minus 25t plus 36 equal to 0. Now, because of space, I'm not going to show the work as to like how we're going to factor this, but what you want to do now is you want to factor this. You want to factor 4t squared minus 25t plus 36. And if you factor this, you're going to end up with 4t minus 9. Let me rewrite that. And t minus 4 equal to 0. All we did, we factor out the left side, but we don't have enough space, so I'm just going to write down the factor. And now, once we have it in this form, we have what is called in factor form. And when two parentheses, they're multiplying and they're equal to 0, what you have to do is just let each parenthesis be equal to 0. So this is my first equation. This is my second equation. Well, let's solve for the first one here. So now we have that t is equal to 4. Cancel. So we have 4t equal to 9. And we got that t is equal to 9 over 4. So here we got two answers. Here we got that t equals to 4 and t equals 9 over 4. But notice one thing here. It says here that t represents the time from its origin in hours. So we want whole numbers here. And 9 divided by 4 is not a whole number. So we don't take this as an answer. We just want t equals to 4. Because again, it says here that t represents the time from its origin in hours, full hours, 1 hour, 2 hour, 3 hours, not decimal representations. Because 9 divided by 4, that's about 2 point something, which is not fine. We want hours here. So the only answer here is when t equals to 4. Now, if we look at the last sentence of this problem, it says, how much faster was the tidal wave traveling after 1 hour than 3 hours? 2 nearest mile per hour. And now we got to justify our answer. So we do have a formula. We have a formula here. And we remember our formula looks at S equals the square root of t minus 2t plus 6. So this is the general formula here. We have it. Now, what we want to do is says, how much faster was the tidal wave traveling after 1 hour than 3 hours? So what we want to do here is, let's see what happens when, let's see what's a tidal wave after 1 hour. Let's see what's the tidal wave at 3 hours. Let's take the difference and we get our answer. All right, so let's see what happens when we have 1 hour. what is the tidal wave? Well, S equals, if it's 1 hour, that means that T is equals to 1. So we got square root of 1 minus 2T plus 6. So that means that S is equals to 1. The square root of 1 is 1. Oops, I'm sorry. Forgot to substitute T here. Perfect. 2 times 1, that's 2 plus 6. And if we simplify this, we're gonna get our answer is 5. So S is equals to 5. So at least in 1 hour, we got the tidal wave is 5. Now, what happens when we got 3 hours now? At 3 hours, we got S equals to square root of 3 minus 2 times 3 plus 6. Because again, all we're looking at the equation, and we're going to substitute T for 3. And this is what we have now. So now we have S is equals to the square root of 3 minus 6 plus 6. But notice here, they're going to cancel out. So here we have that S is equal to, let's leave it as square root of 3. So now we can actually answer our question now, because it says, how much faster was the tidal wave traveling after 1 hour than 3 hours? So if we look at the difference here, we're going to get the first hour, we know the tidal wave was 5. And when we take out the value for the tidal wave when t equals 3, we have the following. If you do this in the calculator, you're going to get 3.268. All right, so we know that the difference is 3.268. But notice here that we need to convert this into miles per hour. So all we got to do is just move the decimal place for the final answer. All we got to do here is just, we know the difference is 3.268. We gotta make this into miles per hour. So all we gotta do, we're gonna get our decimal place, move it 2 units to the right. So this gives me 326.8 miles per hour. But it says here that we need to round it to the nearest mile. So instead of 3.26.8, all we gotta do is just 3.27 miles per hour. And this is it. This will be the conclusion for our last example for the Regents review for January 2017.